In this video, I am discussing first 15 physics questions of Grand Test 1. Here, to find out dimensional formula for any physical quantity, first we have to write formula. Here, resistivity of a wire is rho. Resistance R is equal to rho L by A, where L is length of wire, A is area of cross section, R is resistance of a wire. So by Ohm's law, V is equal to I by R, so IR. So here V stands for potential difference, which is calculated by using the formula work done in bringing unit charge. Work done dimensional formula, since we should express in terms of Q I am not changing. So current through the conductor is rate of flow of charge. Right. So here rho equal to RA by L. R here is VA, V by A, VA in place of I, Q by T of L. So potential difference is ML square T power minus 2 by Q, area dimensional formula L square T by Q and L here, which is ML Q power minus 2 T power minus 1. This is answer. Second option is correct. Second problem. Particle is aimed at a mark in its same horizontal plane as the point of projection. It falls 10 meters short of the target at an angle of 75 degrees. So when it is projected, at certain angle, it reaches target. But since it is projected at 75 degrees, 70 degrees, it reaches 10 meters short. Somewhere here. which is 10 meters. Here, angle of projection is 75 degrees. When it is projected at an angle of 45 degrees, it is 10 meters ahead. So range here is OA. O is point of projection, which let us say it is projected with a velocity u at an angle theta. So when it is projected at an angle 75 degrees, it reaches B, which is u square sine 275 g, u square sine 150 by g is r minus 10. When it is projected at 45, it reaches a point C, u square sine 245 sine 90 is 1, which is r plus 10. From adding these two, we get 2r is equal to sine 150 is half, which is 3 u square by 2g. Here r is 3 u square by 2, which is u square sine 2 theta by g. Sine 2 theta here is 3 by 4. Sine inverse theta is half sine inverse 3 by 4. Answer 1 is correct. Radiation of wavelength incident on a hydrogen sample. So what happens? It absorbs the light and subsequently emit radiations of 10 different wavelengths. Number of spectral lines n times n minus 1 by 2. From here, 20 I can write, n value here is 5. So here Rydberg formula one by lambda is equal to r into 1 by n1 square minus 1 by n, where r value 1.097 into 10 power 7 meter inverse. Here, N1 is a ground state and N2 here is 5. So 1 by lambda is R into 1 minus 25, 24 by 25 R. Redberg constant 1.097 into 10 power. Lambda is 25 by 24 into 1.097 into. So it is roughly 1.09. You take it as 1.1, which you get 25 by 26 into 10 power minus 9, which is approximately 0.95 into 95 into 10 power minus 9, or 95 nanometers. 1 nanometer is 10 power minus 9 meters. Here in this problem, we have established coefficient relation between coefficient of restitution. So, four cases he given: collision between two neutrons. In general, it is elastic collision. So coefficient of restitution is 1. In case of B, bullet get embedded in block after collision. It is an example of inelastic collision, complete inelastic collision. So E is 0. C, body dropped from a height 4 meters and it rebounds to a height 1 meter. There is a loss of energy. Perfectly, it is inelastic. It's definitely inelastic collision. So here it may not be completely inelastic, semi-inelastic. E here is root of H2 by H1 half. In fourth case, body is moving with a initial velocity. It is related to one body. Second body, identical body. Both are having same masses, which is at rest. And the first body comes to rest after collision, while the other body moves with a velocity 4 meter per second. So what type of collision we don't know. If it is elastic collision, velocity of separation must be velocity of approach. So here 4 minus 0 is 10 minus 0, which is not true, which implies collision is not elastic. So if it is inelastic, so E value here is V2 minus V1 by U1 minus U2. That is 4 by 10.4. So here it is. In increasing order, in ascending order, which has least coefficient of restitution. So obviously B, then D, then C, then A. So option is right. Option 4 is correct. This problem, equiconvex lens made of glass of refractive index of focal length, and it acts as a concave lens when dipped in a liquid. So here, lens maker's formula 1 by f is equal to mu glass by mu air 1 by R1 minus 1 by R2. Equiconvex R1 equal to R2. Okay. Here it is. If surrounding medium is air, let us say it has a focal length. When it is dipped in a liquid, so surrounding medium becomes liquid. Say this is first equation, second equation. Dividing one with other, mu glass by mu liquid. So here glass refractive index is given. Air refractive index is 1. Liquid refractive index we don't know. So here it is 1.5 minus 1, 1.5 by refractive index of liquid, which is F2 by F1, 0.5, 1.5 by mu L. He told after dipping lens in a liquid, it behaves like a concave lens. So focal length of concave lens is negative, which implies F2 here is minus 0.5. So minus 0.5 by F1, 0.5 by mu L minus 1. So 1.5 by mu L minus 1 is focal length is 0.2. It is 2 by 10. So 1.5 by mu L is which is equal to F1. F1 here is 0.2, which is 1.2. Mu L here is which is 0.8. 1.5 by 0.8, which is 15 by 8. So second option is correct. Here, photoelectric emission is observed on a metallic surface for a frequency, so nu1 and nu2. The maximum values of kinetic energy of photoelectrons emitted in two cases are in the ratio. He is asking threshold frequency. So we know Einstein's photoelectric equation. A light of frequency nu1 is incident on metallic surface. So then h nu1 is h of additional frequency plus kinetic energy max. Similarly, when frequency of light of frequency nu2 is incident, h of kinetic energy maximum. So what he given is maximum kinetic energy ratio he given Ke1 is to Ke2 is 1 is to K. So from rewriting first equation, H nu1 minus F is K1, H nu2 minus F is K2. Dividing one with other, we get nu1 minus F by nu2 minus F. K1 is to K2 is 1 is to K. So nu1 K minus Kf is nu2 minus F. F into K minus 1 is nu1 K minus, which is K nu1 minus nu2 by answer. Second option is correct. So in this problem, in the absence of electric field, charged ion drop is falling free. So when charged drop is falling freely, so in air, here mg is equal to drag force, that is 6 pi eta rv. So it is held stationary in electric field. So when electric field E is applied, so it is stationary. It is stationary. That is, so mg is equal to, this is nothing but force on charged oil drop. This is second equation. So after some time, it acquires a charge q and it moves with a velocity of 3u upwards. It's missing. So when it rises with a velocity 3u, mg definitely acts downwards when it is moving upwards. So frictional force, drag force will be downwards. That is 6 pi n into theta e, and it acquires additional charge due to electric field. That is, it is having charge q and mass m. Force on this action will be E times originally q. It acquires a charge capital Q additionally, which is mg plus, it's with a velocity. So drag force will be 6 pi eta 3 times with what velocity it is rising. With same velocity we have to consider. We know that this pi 6 pi eta v is nothing but mg, which is 4 mg. So EQ plus E capital Q, which is 4 mg, which is 4 QE. From here, EQ will be 3 QE. So additional charge which it acquired is 3Q. Answer 3 is here. A simple pendulum is hanging from the roof of a car moving with a uniform acceleration. Pendulum is displaced 30 degrees from the vertical relative to the car. So here, let us solve the problem with respect to non-inertial frame. That is, so in car frame of reference, that is accelerated frame of reference, pseudo force acts on bob with the same acceleration but in opposite direction. Pseudo force, that is with respect to car frame of reference, that is accelerated frame of reference. So what are other forces acts? That pseudo force is, which is MA, tension developed in the string. Let us say theta here, its weight acts downwards. It's, this is theta, theta. Here tension component vertically T cos theta horizontally, T sin theta. So this is nothing but equating the forces horizontally and vertically. Say this is 1, dividing 1 with uh, tan theta is theta already he given it as 30 degrees. Tan 30 will be from here A is G by root 3. Pseudo force, so ME, which is mg by root 3, be also correct. So to find out tension, any equation let us consider theta is 30 cos 30 root 3 by 2, which is mg. T here is 2 mg by root 3. So all three options are correct. Here, fish looking up through water sees outside world containing a circular origin. So here is water, which is denser medium. Here is air, rarer medium. Light rays travel from denser to rarer medium, experience a total internal reflection. So for certain angle of incidence, so it gets totally internal reflected. That is, angle of refraction is 90 degrees. So here, this angle is critical angle. So like that, light can travel in all the directions. So the fish can see only restricted region. After that, light rays gets reflected. What he is asking, the radius of the circle. So this is height h and radius r. This is critical angle. So tan c will be r by h. So, and to find out critical angle, if we apply Snell's law, mu water sine critical angle, mu air sine 90 degrees. 4 by 3 sine c. So from here, sine c is 3 by 4. Tan c will be 3 by 16 minus 9 root 7. R value, we don't know, He given. We have to find radius, which is 12 root 7 centimeter. Answer 3. Third option is correct. Here, a uniform chain of mass of length L is kept horizontally on the table with the half of the length is hanging. So hanging part L by 2. Taking this as a reference level, since mass is not distributed, not concentrated at one place, it is distributed. So here potential energy of chain that is hanging part is m, so half of the chain, the total mass is m, half the chain, mass of half of the chain is m by 2. Its total mass is not concentrated, so then we have to take center of mass, distance from center of mass to the reference level as height, that is L by 2. It is in fact 1/5 half of the chain, right? L by 2 by 2. That is mgl by 8. Now in the second case, work done in pulling the chain on the table so that 1/5 of the length is hanging. So here 4/5 is lying on the table, 1/5 only hanging. So the potential energy of hanging part, first of all, mass of hanging part, it is only 1/5, mass obviously proportional. Potential energy will be m by 5, L by 10, because mass is not at one place distributed. Effective height from the reference level is this 50. So change in potential energy is mgl by 8, 25 mgl minus mgl, 21 mgl by 200, which is work done. So option 4 is correct. In this problem, maximum tension of the string of oscillating pendulum is twice the minimum tension. Once pendulum starts oscillating, you can get maximum tension at the mean position and the minimum at extreme position. So in extreme position, it makes an angle theta with the vertical. Its mass is m, forces acting will be mg, and length of simple pendulum is L. So when it reaches extreme, it will be at height from the reference level. So this is length of the pendulum L. So this will be L cos theta. Obviously H will be L minus L cos theta. Let us name the extreme ending positions as B comma. So at B, uh, it has only potential energy, that is mgh mgl into 1 minus cos theta. At A, it has only kinetic energy of mb square. So by conservation of energy, mgl into v square is 2gl. V here is, okay, let us keep as it is. And regarding tension at B, so this is theta component of height, tension at inwards, the net force will be T minus mg cos theta. There is no velocity. Tension at B will be mg cos theta. At A, so it's moved with a velocity v. So it's moving in a circular path. It has a centripetal acceleration. So that is centripetal force T minus centripetal force is this. Here in with respect to bob frame, if you take, so there is a centrifugal force numerically same as centripetal force, which is equal to mg. So T here is V square is nothing but 2gl into 1 minus cos theta from 1, which is mg. So T minus 2mg plus T here is 3m. This is tension at A. What he given is tension at A is twice the tension at B. G minus 2mg cos theta, which is 2 times tension at B. From here, 4mg cos theta is 3mg cos theta. Here is 3 by 4. So option 2 is correct. The moment of inertia of a rod at an axis, the center is, this is obvious. The rod is bent in the middle so that two halves makes an angle 60 degrees. The moment of inertia of the bent rod about the same axis. So once it is bent at the middle, its length is L by 2, L by 2. So moment of inertia of a rod about an end, we have a formula ml square by 3 here. In this case, so mass becomes, length is solved, mass also L square by 2 by 3. ml square by 4 into 2, 24. Similarly, rod OB, moment of inertia, also same. So net moment of inertia about OC is ml square by 24 plus ml square by 24 ml square by 12. Second option is correct. So nothing to do with any this angle. It's 60 degrees or 70 degrees. The same result. So in this problem, 10 grams of ice at minus 20 degrees centigrade added to 10 grams of it is at higher temperature. So it becomes a hot body. This one is a cold body. When they mixed, hot body obviously loses temperature, cold body gains temperature. In this process, total ice may melt, may not melt. So here, let us take water at 0 as reference level. So here ice at minus 20 degrees centigrade, specific heat of ice 2100 joules per kg per degree centigrade. And here, so to convert ice at minus 20 degrees to ice at 0, amount heat required same state, solid state, 10 grams. Unit is given in MKS system. I am converting mass in terms of kgs. Delta T 0 minus 20, which is 420 joules. So to convert 10 grams of ice at 0 degree centigrade to ice water at 0 degree centigrade, for each require 80 calories. For 10 grams, that is 10 into 80 calories, 800 calories, which is 800 into 4.2. This many joules of heat is required to convert ice at 0 to water at 0. So with respect to reference level, so what is the energy associated with 10 grams of water at 50 degrees centigrade? So here MS delta T, mass is 10 grams, specific heat of water 4100, delta T 50 minus G. So it's a grams. I'm converting in terms of kgs. So here we have 2100 joules of energy is associated with the hot part. But so here to melt ice to water, this much is there, but available energy is this. Total ice cannot be melted. So first, what part of energy is utilized to convert ice at minus 22, ice at 0 is 420. So the remaining energy will be 1680 joules. That is nothing but 1680 by 4.2. You get converted 400 calories. So convert 1 gram of ice at 0 at 0. We require 80 calories. With 400 calories, only 4 gram of ice is melt. So the remaining 5 grams will be total amount of water. 10 grams of water is 5 grams of ice is melted. So amount of water is 15 grams. Ice which is not melted is 5 grams. Second option is correct. Here, mass and radius r is rolling without slipping on a horizontal surface. So here velocity of center of mass of cylinder is omega naught r. When cylinder when it hits the point P corner, so here the forces acting at this point will be so the surface cylinder, that is normal reaction. Which passes through the center of mass, and another force is its weight. So here, so assuming torque due to weight is negligible, and here torque with respect to point P will be 0, because here normal reaction passes through P. If at all torque is there, torque due to weight, that is, so here it is negligible due to large impulsive forces. So then angular momentum is conserved. So either angular momentum or torque we will take about the some point. So is conserved about. So before collision or after collision, so it's rolling without tipping. So before collision, how do we calculate angular momentum? It is moving with a velocity v is equal to omega naught r. Angular momentum will be, since it is rolling, one is due to translation, other is due to rotation. Due to translation, mvr plus I omega. This r will be perpendicular distance from with respect to which point you are calculating angular momentum and velocity direction. This total height is r. We given it is r by 4. This will be 3r by 4, which is mv in place of r is nothing but this distance. It's not r, it's 3r by 4. Let me write this as small r, 3r by 4. Since it is a cylinder, so by default you have to take it as a solid cylinder. So since it is initially moving with a angular velocity he given, so it's a pure rolling. V is this is nothing but r naught omega into 3 by r. It is so 3m r in place of v r omega naught by 4 plus m r square omega naught, which is nothing but 2 plus 3 after finding LCM of m r square omega naught by 4. So after collision, again it is rolling, but not with same velocity. So different velocity mv dash. So it's pure rolling. So point of contact are about the same point of contact you calculate it. Here this will be velocity will be in this direction mv dash. So distance what we have to consider is perpendicular distance from the point you are calculating, from that point to velocity direction, you have to calculate the distance, which is r, plus rotation, it is half I omega 1 square. Since it is pure rolling, V dash will be r omega 1, which implies angular momentum after collision. mv dash is r omega 1 into r, where it is I here is half mr square omega 1, which is nothing but 3 by 2 mr square omega 1. So since momentum is conserved, 5 mr square omega naught by 4, 3 by 2 mr square omega 1, mr square get cancelled. So omega 1 here is 5 by 6 omega naught. So option 1 is correct. Here, in this a capacitor has two plates. One is having area of cross section A, other is A dash, and separation between the plates is D, then its capacity. Here is CV. So C is A epsilon naught by D. Generally, we solve the problems where both plates are having same surface area, then field lines will be due to charges get deposited is in the common area only. So here we have to consider common area. Since he said A is less than A dash, so common area will be A only. So the capacitance will be A epsilon naught by D, which is fourth option is correct. So remaining questions I will discuss in the next video.